This video is going to take a look at the driver that uses pointers, which then uses what we call polymorphism, so that when I'm working with Enigma and Slither, which are a mammal and a reptile, it's calling upon it's not using, it's using a pointer to an animal, but it knows that it should call on the mammal code for the mammal and it should call on the reptile code for the reptile. So that's the idea of polymorphism. So we've got our typical pound includes vector is used in this one. And notice we include all of the header files for animal, mammal, and reptile. So we need all of those header files in order to make this work. We are going to declare a type definition. This is just a shortcut to allow us to, rather than always typing in a vector of animal pointers, we can just refer to that as zoo. So this type of definition there is going to replace, if I were to do something like vector animal pointer, and I'm not typing it exactly correctly, animal pointer, and then I do something like my zoo, and then every time I reference it I'm going to have to call my zoo. So it just allows us to use every time I want to use vector of animals, I can just say it's the zoo. So it's kind of a little bit of a shortcut. And that is allowable outside of main. Also notice I have two prototype lines here. One is for a zoo report that passes in a zoo by reference. Remember the ampersand there means that you're passing by reference. So you're passed by reference. And then we're going to look for here, feed animal. And that also accepts a zoo by reference and an integer. And so remember that the entire zoo, remember that a zoo is a vector of animal pointers. Okay, they're not the actual animals, they're animal pointers. So a pointer is just a memory location, and we're going to point to that memory address. We set our total food to 0, and then we have a choice because we'll use that a little bit later. By using pointers to animal for the new mammal and reptile, we're going to avoid object slicing. So in other words, the functionality or the properties of the derived class are going to be used when they're supposed to. So a mammal methods are going to be used when it's a mammal. A reptile methods are going to be used when it's a reptile. The way to accomplish that is when I create a new mammal, Enigma, it's going to be created as a pointer to a animal. So animal pointer, that's what this animal asterisk here means. So I'm creating a mammal that is an animal pointer. And that allows me to put that into I have a vector then of pointers. And so I'm going to load a vector with these. And the second one here is creating a reptile that is an animal pointer. So it allows for to use the superclass objects, the superclass definitions for everything, the superclass getInfo and setter methods and getter methods for an animal. All the things that are in common between mammal and reptile can now be used, and the additional functionality that is created in mammal and reptile are then also automatically used or available. In order to fill a vector, we use push back. So right here we are filling the vector. So we push back the pointer to a cat, pointer to a snake. The PTR here for pointer is not required. I could just name it cat, but it's a typical naming convention to use PTR when you're naming a pointer. And now that it's in a vector, vectors are very nice to use because instead of having to know the size ahead of time, I can use this dot size method here. And so I have a loop that just runs through my vector. If I were to fill the zoo with 12 more animals, this would automatically go from indices 0 through 11. And so it works just like an array. I use the array notation here, except I do have to use this special pointer notation because I'm now working with a pointer. So instead of a dot operator, I do have to use this pointer right here when I get the name. And so I'm using a pointer to an animal, so I have to use this special notation right here. And it asks which animal I'd like to feed, and that's where we use the variable choice. I send in the entire zoo, which is a vector of animal pointers, to my choice or feed animal, and then I also send the entire zoo to the zoo report. Very, very last thing that will happen is that the total for the zoo food total is going to be calculated. So right here, if you take a look, they go ahead and cycle through and get the totals of all of the animals' foods in the vector. So this processes the entire vector, and that's how they calculate the total amount of food. It's not using a static class variable like some of our earlier examples used. So here is where they calculate the total food for each animal and gets the total food for the zoo. Since we've allocated resources on the heap, the new operator, you need to release those. And so at the very, very end, this is important. If you're going to use these resources on the heap, you have to release them using the delete operator. So you're going to delete that zoo vector. If we go all the way back up, my zoo was that vector of pointers. And you need to delete that vector of pointers to get the memory off of the heap. So remember, in C++, memory management is your obligation or your job. And so that's why we have to do something like this, is to clean up our memory when we are done. We're going to take a look at our two methods, feed animal and zoo report. Zoo report is pretty straightforward. It's going to do an animal report, and it's just going to cycle through. And now here's what's kind of interesting. I can take the entire zoo dot size because it's a vector. Remember, that's because it's a vector. So vectors use the dot size to return that size of the vector. So it makes it very nice for working with a for loop. And then right here, I don't have to tell it whether it's a mammal or a reptile or anything. The polymorphism is at work right here. The pointer behaves like the object of the data type. So because the zoo pointer points to a mammal, then the method for mammal is called. If the zoo pointer points to a reptile, then the reptile method is called. Also note that it's applied if the method is animals are virtual. Sorry, I didn't say that right. It's important to note, though, that this only applies if the methods in animal are virtual. So if we go all the way back to our animal.h class, please notice your destructor was a virtual method, and the getInfo was a virtual method, and the animal type was virtual. So if we don't have a virtual method, that polymorphism is not going to work. If I go back to our driver with pointers, the other thing to note, I think I said it, but I'm going to say it again, is that it uses array notation, but we have to use this special arrow in order to access the pointer information. That arrow is literally just the minus sign and the greater than symbol. So I just typed the minus sign and the greater than symbol. That's how you get the arrow. Okay. Last but not least, when we feed our animal, again, we're going to be using polymorphism. So, and it's just going to ask how much food is needed. So we have this method that asks how much food is needed. We have totally rewritten the feed animal. I believe this was the one that had the select case statement in it before, and we no longer need that because we can just pass in our vector of zoo animals. We can ask locally what they want to eat, and then it's going to access the correct feed method. Actually, our feeding method, I think, stays the same. And so the only thing that we haven't done in this particular, I think, version is I have not tested the changing the temperature on a snake, but I think the video is long enough right now that I'm not going to do that. All of this code is available on course sites, and so even if you don't use pointers and vectors in your semester project, watching these videos will help you when you take your quiz on polymorphism and classes. So that's going to wrap up our zoo example using vectors and pointers. And if we take a look at the output one last time, you can see the polymorphism here was at work because when we did the getInfo, when it was a mammal, it just printed this information, but when it was a reptile, it printed our additional information here. And then you can also see, and this is kind of important, that when I destructed a mammal, it automatically destructs the animal object. So remember, that was a pointer to an animal. When we created the new mammal, both of those objects have to get destructed. And likewise here. And so when you do use pointers and when you're using C++, we have to make sure that we clean up that memory. And that is it.